Okay, so we're looking at this question here. It says, using the financial data provided, compute the discount yield on the 91-day Treasury bill purchased for 93,800. All right, so colleagues, remember Treasury bills. What happens is this: you always buy them at a lower price than the face value or the par value. Okay, remember the par value or the face value of a treasury bill is how much you get paid when it matures. So after 91 days, so for this treasury bill, okay, a 91-day treasury bill is currently being purchased for 93,800 against, excuse me, a face value of 100,000. So this is what's happening. You purchase this 91-day treasury bill at this amount, 93,800. Then after 91 days, you're going to be paid 100,000. Okay. So that this 100,000 that you have paid when the treasury bill matures, minus what you actually pay for the treasury bill, that's the interest that you earn. Okay. That is the interest that you earn. 100,000 minus 93,800. This is not part of the question, but this is just to so that you understanding how these things work and you get context. All right, but it's not part of the question. 100,000 minus 93,800. Yes, you earn interest of 6,200 kwanch. Okay, that is the interest that you're going to earn. All right. So now they're asking us to calculate the discount yield. The discount yield, basically, this is the return that you're earning for buying a treasury bill at a discounted price. Okay. The return for buying a treasury bill at a discounted price, or just basically the return for buying something at a discount. Okay, colleagues? The return for buying something at a discount. That is your discount yield. Okay. So discount yield, this is the formula for it. Okay. The face value minus the price, basically the interest that you're going to earn, divided by the face value, all right, multiplied by 365 days divided by days to maturity. All right. So the face value, 100,000. This is how much you are paid when the treasury bill matures. The price, 93,800. This is how much you're paying for the treasury bill. Divided by the face value times 365 over 91 days. This matures in 91 days. Okay. So 100,000 minus 93,800, you get 6,200 over 100,000. Okay, times 365 divided by 91. So 6,200 divided by 100,000, you get 0.062. 365 divided by 91, you get 4.01. So 0.062 multiplied by 4.01, that is 0.2486. Okay, so the discount yield is 24.86%. Okay, so this is the return that you're getting on this security at a discount. Any questions, colleagues? That's what the discount yield is. Return for buying treasury bills at a discount. Okay. So this 6,200 interest that you're earning represents a return of 24.86%. Okay. Yes. Any questions before we go to part two? We're computing the purchase price, the 182 treasury bill, 182-day treasury bill. Okay. Compute the purchase price of a 182-day treasury bill with a face value of 100,000, trading at a discount rate of 12.8%. Okay, so we're trying to find out how much do we need to pay for a 182-day treasury bill. Okay. How much are we needing to pay? So this is how you get the purchase price. Oh, let me just get some bundles before my bundles finish. Just give me one minute. I don't want to be kicked out. Okay, we can resume. Yeah, so the purchase price is the face value multiplied by 1 minus, open brackets, the discount rate multiplied by the days to maturity over 365. Okay, let me put this properly in a fraction form like this. Days to maturity over 365. Yes. The face value, we already have it, 100,000. The discount rate, 12.8%, which is 0.128. All right. Then here, oh, days to maturity is 182. Yes, 182. Yes. So 182 divided by 365, you get 0.49863. Multiply that by 0.128, you get 0.063824. 1 minus 0.063824, you get 0.936176. Okay, so you start with these tabulations within the brackets here. All right, so 0.936176 multiplied by 100,000, you're paying 93,617.16. This is how much you're purchasing this 182-day treasury bill. Okay. Yes. Any questions? Okay. Now, colleagues, I need you to notice one thing about this question here. Right? We've seen that the 91-day treasury bill is offering a rate of a return of how much is the return was 24 point what? The return was 24.86%. All right. And the 182-day treasury bill is giving a return of 12.8. Okay, let's see. Was it the discount rate or the return? Oh, okay. It's the discount rate, not rate of return. Okay, but this is the point that I wanted to illustrate first. Okay, you need to know about these. interest rate curves, these yield curves for interest rates. Okay. This normal yield curve, what it usually tells you is this: the longer the maturity, the more return you expect. All right. Why? Because you're giving up your money for a long time. So you expect a higher return than someone who's giving up their money for a short time. Right. Yes. And there's also the inflation risk. The more time goes by, the inflation is going to erode your returns. All right. So usually debt instruments with a higher maturity should pay you a higher return compared to debt instruments with a shorter maturity. Okay. Long-term debt should give you higher returns than short-term debt. As you can see this curve as it's growing here. As the maturity grows, the yield is also growing. The return is also growing. Now that's in a normal situation. Okay. That is normally expected. But there are going to be times, colleagues, where short term debt is going to give you more returns than long term debt. This is where I've seen the inverted yield curve here. Short term debt is giving you higher returns than long term debt. The reason for that, okay, in case you ever asked to explain these yield curves for interest rates, okay, the reason why a short-term security can give a higher interest than a long-term security is when government and the economy is in panic. Money is needed right now. Government needs the money right now. So to attract people, to prevent them from buying long-term debt, they'll tell them purchase this short-term debt now so that we can use the money. Okay, the money is needed immediately. Okay, probably the economy is undergoing high inflation or low or deflation. There is in a recession, so government needs the money right there and then. That would be the scenario where this curve is going to be like this, upside down like this. Okay, that's there. The economy is doing bad, and government is needs money right now. All right. Yes. So I just wanted to illustrate that point. Okay. So with these debt instruments, normally long-term debt gives you higher rates than short-term debt. But if there's a situation where short-term debt is giving you higher interest rates than long-term debt, then government is panicking and needs money there. Okay. Or maybe they're not panicking, but they just need the money right there and then. Okay. And there are various reasons why government might need money there and then. Okay. So if this 182-day Treasury bill was giving a return of 12.8%, and then this 91-day Treasury bill is giving you a return of 24%, okay, if that was the scenario, then we are talking about this green curve here. Because 91 days is shorter than 182 days. So you'd expect 182-day Treasury bill to give you a higher return. Okay, but in our example here, it's giving you a return of 12.8. Then the short term Treasury bill is giving you a return of 24%. So there you know that, okay, government really needs the money as quick as possible. Okay, yes. Any questions before we go to part three? Okay. Compute the simple interest rate equivalent of the interbanking lending rate if interest is charged for 45 days on a loan of 500,000. So colleagues, just remember this. We remember this formula from high school or from school. Interest equals principal times rate times time. Okay. The principal, in this case, the money that is being borrowed, the original amount being borrowed, 500,000. The rate, the interbanking rate here, wait, where did I get the 15.5% from? Oh, yeah, here. They've told us in the question here the interbanking lending rate is 15.5%. Okay. They told us in the question the interbanking lending rate is 15.5%. Okay. So here, the interbanking rate, 15.5%. Then it's for 45 days. Okay. So 45 days over 365 days, that will give you, that converts days into a year basically. Okay. Yes. So you just say 500,000 multiplied by 0.155 multiplied by 0.1232. Okay. The interest is going to be 9,554 kwacha point 8 ingwe. Okay. Yes. So that will be the interest that will be needed to be paid. Okay. And that will be the interest also earned by the other bank. Because remember, interest, you look at it at both sides. The cost of borrowing and the return for borrowing. Okay. Cost of borrowing from the lender, the return for borrowing for the, wait, cost of borrowing from the borrower. I'll just name the borrower. Then it's the cost, then it's the return to the lender. Interest is the return to the lender, but the cost to the borrower. Yes. All right. Any questions?